an atom of carbon and a mass of sulfur are going to weigh different amounts. However, if we convert it into moles, we can compare all the different kinds of compounds. We can compare sulfur and carbon. So what a mole is, if you'll remember, is kind of like a dozen. And if you think about a dozen donuts, it means you've got 12 donuts. If you have a mole of donuts, you have 6.022 times 10 to the 23rd donuts. So when you think of moles, just think of it being the number of things that you have. And so um, if you have 6.022, or a mole, if you have 1 mole, you have 6.022 times 10 to the 23rd particles. And particles can mean either atoms, like a carbon atom or copper atom, or molecules. Molecules meaning like H2O or methane, CH4. And so what we're going to do in this video is show you how to convert between moles and grams, moles and particles, and also all the way from grams to the number of particles. And so before we even do that, we have to learn about something called molar mass. And you'll also see this also known as formula mass. And so what this is the mass in grams of 1 mole of a substance. And so if you would find the molar mass of carbon, it would be 12.01 grams in 1 mole. And the place that I got this is I just look at our periodic table. Go that far. And carbon right here has its mass number of 12.01, which is the mass of 1 carbon atom, and it's also the mass of 1 gram of 1 mole of a substance of carbon. Okay, and so if we're going to take the mass of NH3 or ammonium, what we would do is we'd have to take nitrogen plus the mass of 3 hydrogens, like this. And so what we do is we look at our periodic table, and we see that nitrogen is 14.01 grams. Again, we can't forget per mole. And we're going to add that to 3 times, and hydrogen is 1.01 grams per 1 mole. And if we add that all together, what we get is 17.03 grams per 1 mole of NH3. And so it's really important that we can calculate the actual molar mass of something, because this is going to be really helpful in actually going back between our different conversions. So this is molar mass. And so we're going to try this out. If we're going to go from grams to moles, what we need is the molar mass. So what we're going to do is, if we've got 20 grams of NH3, what we need to know is what's the molar mass of ammonium, NH3. And we did that in the last page, so that it was 17.04 grams per 1 mole. And so what I'm going to use is dimensional analysis or stoichiometry. I'm going to take my 20 grams of NH3, set up my conversion factor here. I'm going to put grams on the bottom because that's what I want to cancel out. And I'm trying to get to moles, which is going to be on top. And so how many grams are in a mole? Well, there's 17.04 grams in 1 mole of NH3. I'm going to put 17.04 right here. And so 20 times 1 divided by 17, grams is going to cancel. I'm left with moles. And the answer I get is 1.17 moles of NH3 in 20 grams of NH3. And we can do the same thing, but in reverse. We can take the number of moles of something and convert it into the number of grams of something. And again, we're going to need the molar mass to do that as well. So if we have 3.5 moles of carbon in grams, we're going to have to calculate what our molar mass of carbon is. And we did that in the last slide as well, and it was, we just looked at the periodic table, found the mass number, and it was 12.01 grams per 1 mole. So what we're going to do again is some stoichiometry, some dimensional analysis. Write down 3.5 moles of carbon, and we're going to convert that into grams of carbon. So moles is going to go on bottom, grams is going to go on top. And so again, how many grams are in 1 mole of carbon? It's 12.01 grams per 1 mole. Moles are going to cancel. And now I'm just going to run 3.5 times 12.01 into my calculator, and I should get 42.04 grams of carbon in 3.5 moles of carbon. The next calculation that we'll need to be able to do is going from moles to particles. And so instead of using the actual molar mass or formula mass, what we're going to use is Avogadro's number, which is 6.022 times 10 to the 23rd. And so what we're going to write down is our 3.5 moles, like so, trying to figure out how many particles, atoms, or molecules are in this amount of moles, 3.5. So what I'm going to do is do my stoichiometry, my dimensional analysis. I'm going to put moles on the bottom so it cancels. I'm going to put particles on top. How many particles are in 1 mole? There is 6.022 times 10 to the 23rd particles in 1 mole. And so I'm going to run this in my calculator, and it's always important to put this in parentheses in your calculator so the order of operations doesn't get off. So it's 3.5 times 6.022 times 10 to the 23rd particles, and my answer I get is, and then moles is going to cancel here, and I get 2.11 times 10 to the 24th particles. And I can do the same thing going from particles to moles. And so if I have 5 times 10 to the 24th particles, 4 particles, and again I'm going to need Avogadro's number to do this. I'm going to set up my conversion factor here. Particles is on bottom, moles are on top, and in 1 mole I have, again, Avogadro's number, which is 6.022 times 10 to the 23rd particles. And so I'm going to see particles cancel out. I'm going to take 5 times 10 to the 24th particles times 1 divided by 6.022 times 10 to the 23rd, and I should get 830 moles of a substance. And what I want you to notice is I didn't specify in either one of these what substance I was looking for. And that's because it doesn't matter. Once you've converted it to moles, it's all going to be the same. There's going to be the same number of atoms in 1 mole of oxygen as there is in 1 mole of water, H2O, or there is in 1 mole of sulfur hexafluoride. So 1 mole, again, is going to be the same for all substances. And also notice that every time we have a mole, that's what 1 is going to be. Okay, so there's every time we have the mole unit here in our conversion factor, that's what it's going to be, over 1 or under 1. And so the last conversions that we need to be able to do are between grams and particles. But what's important is that we can't go straight from grams to particles. We can't figure that out. We have to convert it first to moles and then to particles. So if you have 5 grams of carbon, we're going to have to convert this into moles first, and then we can convert it into particles. And so I'm going to set up my dimensional analysis, stoichiometry. Grams is going to be on the bottom, moles is going to have to be on top because I'm converting from grams to moles. And right off the bat, you should notice if there's a grams per mole, this is going to be molar mass, or formula mass. And so if you remember from a couple slides ago, we just need to look on the periodic table. What's the molar mass of carbon? Well, there's 12.01 grams per 1 mole of carbon. And so the grams will cancel. Now I'm going to convert moles into particles. I'm going to put moles on bottom so it cancels. And what I'm going to put on top is particles. And right off the bat again, if you see particles per mole or moles per particle, what we should see or what we should identify is this is going to be Avogadro's number. That means this is going to be particles is going to be 6.022 times 10 to the 23rd per 1 mole. And so my moles will cancel and my final answer will be in particles. So what we're going to do is we're going to take 5 times 1 divided by 12.01 times 6.022 times 10 to the 23rd particles divided by 1, and our final answer should be 2.5 times 10 to the 23rd particles. And in this instance, it's going to be atoms of carbon, if you want to be more correct. Okay, and so we're going to do this one more time. Just like we had to go from grams to particles, or we couldn't go straight from grams to particles, we can't go straight from particles to grams. We have to go to moles first, because moles is something we can compare. So if I'm going to set this up, I'm going to take 1.2 times 10 to the 24th, which would be a 4, not a 9, particles, H2. And I'm trying to figure out how many moles I have. I'm going to put particles on the bottom and moles on top. And so again, if you have particles per mole, what number do you need? Hopefully you've answered this one. You need Avogadro's number, which is 6.022 times 10 to the 23rd per 1 mole. Particles are going to cancel out. We've gone straight from particles to moles. And so now we just need to go from moles to grams. And if I want to cancel out moles, I'm going to put moles on bottom. I'm going to put grams on top. And so right here we should see grams per mole. This is going to be molar mass. And so I have 1 mole here, and I need to ask myself, well, what's the molar mass of H2? And so what I need to do is go to my periodic table, and what I find is that hydrogen by itself weighs 1.01 grams, and H2 is, well, 2 hydrogens, so we're going to multiply that by 2. And so my answer should be, for molar mass, should be 2.02 grams per 1 mole. And so that's what I'm going to put right here, is 2.02 grams per 1 mole. And so now my moles can cancel out. And when I put this in the calculator, it's always important if you have these, put these in parentheses on your calculator so the order of operations is correct. And so 1.2 times 10 to the 24th particles divided by, or times 1 divided by 6.022 times 10 to the 23rd particles times 2.02. And the number, the final answer is 4.02 grams of H2. So again, moles is going to be how we get from particles to grams and grams to particles, and it's all hinging on being able to find the molar mass as well.